and hopefully, yeah, we'll see how we do. Alright, how about this?
Okay, so initial velocity. So that means that if r is horizontal, u is equals to 40.
I don't believe so. I believe 40 would be like that.
Okay.
And so at this angle.
Do I need to solve for alpha or something? Or?
We could. Let's see. So tan is opposite, or you could do it that way. This would be an exact value. You could solve for alpha. Let me keep that actually. Oh, this thing. What would be sine alpha? What would be cos alpha? Do it that way.
Okay, so is it sine alpha or arc sine alpha?
Sine alpha.
Sorry, is arc sine of 3/4 or sine of 3/4?
Forget it. Let's just go for alpha. What's alpha?
Alpha is this is going to be in radians, isn't it?
No.
Oh, well, I got a bad number.
36.7.
Yeah, 36.8.
Grand. What would be the horizontal component?
So what I need to do, like, so it's opposite over adjacent. So, I'm sorry. What mum's calling me, so I just need to tell her to.
All right.
Okay, choose. Sorry. So, I'm not sure.
So that would be the horizontal component, the I. That would be the base.
Yep.
So what is adjacent in the triangle?
Is that I or something?
Like hypotenuse, adjacent.
Yeah.
Cos. What is cos alpha?
Adjacent over hypotenuse.
Okay. What is the adjacent?
hypotenuse times cos alpha.
Yeah. What's hypotenuse for this one?
40.
And cos alpha. Do cos answer. What do you get?
So I'm doing. Sorry, what am I doing? Sorry.
Cos answer of the thing you previously got.
I got 1.
This is what I'm getting. So you did arctan and you got 36.7 or whatever?
Yeah.
And so cos of that?
So, 0.8, yeah.
And so it is 40 times that.
Which will be 36.
That's it. And so 36 is the adjacent, which is also the I. So that's like 36I. Okay, how about the J direction?
So now we're doing with the opposite. So is that now going to be like sine?
Yep.
So sine alpha equals to opposite over adjacent, or over hypotenuse, sorry.
Opposite over hypotenuse, yeah.
And so that'll be sine alpha equals to opposite over 40. And so 40 sine alpha equals to opposite.
Mm-hmm.
And for sine alpha, we just did 40. So we do need to do 40 sine arctan of 3/4.
Yep.
And I got 24.
Well done. So that's 24J. And so overall, it is 36I plus 24J. And, oh, that was part B somehow. Given that the vectors, find the horizontal and vertical components. Is it just 36, 24, and then express the initial velocity as a vector? 36I plus 24J. 32. Did you multiply it by 40? 32.
I did 3/4. I don't know.
Ah, okay. So that's 32.
Yeah.
32. I, 24J. 30. Yeah, they just did the two separately. And then from there. In general, the I direction is, like the X direction, is F cos alpha. J direction, F sine alpha. So force times cos alpha, because that's the adjacent. Force times sine alpha, because that's the opposite. Any questions about that?
No.
Okay. That's that question. Let me see. Yeah, let's give this a go.
So we need to draw this.
If you like.
So if we have like the I and J and stuff, and the initial velocity is like 15 ms, an angle of 25 degrees. Yeah. And so we're just doing the same thing with SOHCAHTOA and stuff.
Yeah.
So it's just the so I've got my hypotenuse and I've got. Could I do sine of 25 equals to oh no. Oh yeah, sorry. So sine of 25 is equals to opposite over 15.
Yeah.
And so 15 sine 25 is equal to the opposite.
Yeah.
And so that'll be 6.34. And now it's cos 25 is equals to adjacent over 15.
Mm-hmm.
And so it would just be 15 cos 25,
Mm-hmm.
which is 13.6.
And part B?
Is this just 6.34i plus 13.6j?
13.6J. Got it. And you could also say it's 15 sine 25 J. Ooh, hang on. The sine is the J. Which one did you? Oh, the way around.
Okay, oh yeah, sorry.
The way around. Yeah. Let us make sense of this thing. So 13.6I plus 6.34 J. Just want to see what that old book you want. Okay, 3 sig fig. 6.34 J. Make sense of it. What are we doing? This just means, so this kind of whole number one, 32I plus 24J. This thing got projected at an angle with a certain amount of force. That means for every 32 right, it went 24 up. Something like that. No, excuse me. It went 32 units right and 24 up. Or in terms of the angle, it would be for every 4 right, it went 3 up. But it went exactly 32 right and 24 up. That's all we're doing. So we're converting a force and an angle into kind of its parts. They call them components. So how much right, how much up. Not just 4 right for every 3 up, but actually 32 right, 24 up. That type of thing. And here it was like to 3 sig fig, but it's the same idea. 13.6 right, 6.34 up, roughly speaking. Okay, let's skip to part B. What would it be as an exact answer?
Sorry, are we going straight to B?
Yeah.
And so that will be. Can we draw again?
No, don't need to.
Okay. So is that just F cos?
What's F?
No, 8 cos 10 plus 8 sine 10. Yeah, I and J.
Sine 10 J. What is 8 cos 10?
7.88.
And I got 1.39 for the other one. 7.88, 1.3. Okay, so this one was negative. Was there something to that negative thing? Below the horizontal. Okay. So, yeah, I suppose it would be like that. But fair enough. Okay. Any questions there?
No, so that's just the formula basically anytime that kind of question comes up.
Yeah, and it's because cos theta is adjacent over hypotenuse, and so the adjacent, which is the horizontal component, hypotenuse times cos theta. The opposite is hypotenuse times sine theta, and that's why it's f cos alpha, f sine alpha. Okay, reverse. They give us the vector. We have to work in reverse to get what the original angle and force were.
Okay. So am I just doing the opposite thing here and saying something like 3 is equals to f sine alpha, or was it cos alpha? F cos alpha, I think.
Yeah.
And 5 is equals to f sine alpha.
Mm-hmm.
Oh, I get it. And then will it be something like, so f tan alpha is equals to 5/3?
What's f divided by f?
1.
Yeah.
So it's just tan alpha.
Yeah.
It's 5/3. And so so I need to do op and of 5/3.
Mm-hmm.
And I get 59.0.
Okay. Initial speed.
Do I need to draw this out again?
No. Simultaneous equations. You got one answer.
So is f the speed?
Yep.
So I can just do f sine 59 equals 5 and solve from there.
Yeah.
And so I get I got 5.83.
So that times something, equals 5. So shall be 5 divided by that. 5.83. Looks good to me. F equals 5.83 meters per second at an angle of 59.0 degrees. 59 degrees, and they're saying the initial speed was root 34. That's another way to do it, a better way to do it. Let me just see, root 34 probably works. Yeah, same number. Let me just go up for a second. Yeah, this isn't going to give me an exact value. The initial speed is Pythagoras for 3 and 5. And I suppose if you had a diagram, you're right. That would be 3, that would be 5. Yeah, and so Pythagoras of those two. Great. Unless there's any questions about that one, I'm I'm looking for an exam question. This one we are good. Hang on. This one's going in group 1. Yep. Exam time.
So
Let me
yeah, so F
hang on.
cos.
Let me be a silly man. I want to make a formula. So kind of sense that this is probably not too bad. So what's a formula for this stuff? F sine alpha. So what was the 5? The 5 was the j. And so tan alpha is equal to the j over the I. And then the magnitude of the force is Pythagoras of a squared plus b squared. I think that'll work. Okay. So tan alpha. All right. If we need to, we can do it bit by bit. Okay, how about this?
Okay, so should I do F cos alpha equals to 4 and F sine alpha equals to 3? And so tan alpha equals to 3/4.
Yep.
And so now I need to do arctan of 3/4.
Yep.
And I've got 36.7, 36.9.
Okay.
And so now I do I can just do F sine 36.9 equals 3.
Do Pythagoras.
So that will be 5.
Yep. And so the initial speed is u, and that is 5 meters per second. Pythagoras with those two gets you the F. The tan of the j over the I is alpha. 36.95. Great. Let's see. That was that stuff. Grand. Sure. What do you give yourself for that stuff?
Probably a tick.
Okay. Projection at any angle. I'm trying it. Let's try this. Okay.
Okay, so is it basically? Do I need to bring up the formula again? F cos alpha plus F sine alpha.
You could. Here's my guess. The greatest height it reaches, I think it might be suvat.
Oh, that's some sort of equation, isn't it?
Yeah, let me just... We could turn it into a vector. Yeah, let's turn it into a vector.
And so now, so is that like I and J?
Yep.
And it says horizontal, and so F is 28.
Yep.
And so am I gonna do at 28 cos 30 equals to,
And is that the I or J?
that's the I.
Yeah.
Plus 28 sine X, I guess, or J.
J.
Yeah.
Sine, and that would be Y. 28 sine 30 J. Calculator. See if it gets simpler.
And so now, so I got 14 root 3 I.
Okay.
Plus 14J.
Okay, great. Plus 14J. Suvat. You're going to make me find these suvat things. I thought I have a better... Yeah, it's a better suvat. Taken directly from the exam. Shizzle dizzle. Razzle dazzle. Okay, greatest height. And like with all suvat, 3 things you know, 1 thing you need.
Okay, and so I know what the U is. So U is 28. Oh, does it matter? It matters if I'm doing it horizontally or vertically, doesn't it?
Yep.
So if I say that I'm doing it horizontally, does it matter or not really?
It doesn't. Let me try something. Let's do it all in one go. So let's just say U is this 14 root 3 I plus 14J.
Okay.
Oh, that might be more difficult. Okay, we'll do them separately. So let's say vertical.
Vertical, so U is 0.
U is definitely not 0. What's the vertical component of the force?
28.
Yep. No. 28 sine 30.
Um, 14.
Yep. So originally, this was, given a force of 28 at an angle of 30 degrees, that means it was like 14 root 3 to the right and 14 up. That's basically how it works. Okay, that's one thing you know.
And so U is 14. So is S 14 root 3?
S is what we want. The height.
A, oh, is A minus 9.8 or?
Yeah.
And T is T.
We need three things. We want S.
Do we know what V is?
Yep.
Is V 28?
No. What's the speed of the ball? What's the vertical component of the speed of the particle at its greatest height?
30? I don't know.
So when we split this up, so we resolve just horizontally. So you have some ball, some particle, and its flight is like that. Goes up, goes down. If we look at just resolving the horizontal thing, its flight will look like this. It'll go up to its highest point, then it'll come back down. See what I mean?
Yeah.
That's just the horizontal thing. So if it didn't actually move left or right, what is its speed at its maximum height?
Oh, it's going to be 0.
Yeah. In the beginning, its speed vertically was 14. When it hits the ground, vertically its speed will be minus 14. And at the height, at its highest point, 0. Okay, that's three things you have. One thing you need. See you that time.
And so now we do should I do S equals to VT minus half AT squared? Oh no, I can't, I haven't got 2. But I could do V squared equals U squared plus 2AS.
Yep.
And so that'll be 0 squared equals 14 squared plus 2 times minus 9.8 times S.
Mm-hmm.
And if I solve that in my calculator, that'll give me 10.
Great. I like that answer. Was it exactly 10?
Yeah.
That's terrifying. Okay. B.
So am I now? So I know what S is. Now I just need to sub the same old stuff in to get to.
Yep.
So could I do, for example, V is equals to U plus A2?
Yep.
And do 0 is equals to 14 plus minus 9.8 2.
You could. Go on.
Okay. I need to solve that, don't I?
Yes.
So, I've got 10/7.
Okay. And so, that's not full marks though. Any idea why not? The time of flight of P is not 10/7.
So we got the time. Is that like just not the time of flight FP or?
No. Any idea why? What you got was the time it took for the particle to go from 14 meters per second to 0 meters per second.
So is time of flight of P like how long P was in the air?
Yeah.
Um. So do I need to have the full length of the particle P which it travelled, or?
Yeah.
So is that 28? No, that's the speed.
What you got was the time it takes from the particle to go from O to its greatest height.
Yeah.
But that's not the full journey. Time of flight is how much time it spends in the air. How much of the journey has it done? The red journey.
Half.
Yep.
So I need to double that.
Yep.
And that'll be 20/7.
That's it. Another way to do it is, remember I said it's projected vertically with a speed of 14. At the top it's 0. Its speed when it comes back down will be minus 14. And so you could say minus 14 equals 14 plus minus 9.8t. And that means you don't have to double it. I suppose double 14 is 28. So whichever way you go about it. Okay, and how about question C?
The distance away. So that's just like, that's not I. I is all of it, isn't it?
Distance is S, displacement.
Yeah. So to get the distance away, do I need to do it like R is horizontal and stuff?
Yep.
And so would that be U is 28? Yeah.
No.
Oh, U is 14. Sorry. So
you said resolving horizontally.
yeah.
Vertically it's 14. Horizontally.
Is it half of that?
No. What was its original force? The horizontal component. It was pushed 14 up. We want how many across?
Is that 28 minus 14 or?
No, it is 14 root 3.
Yeah.
So it's pushed with a force of 28 newtons. Sorry, it's pushed with, so it goes 28 meters per second, but at an angle of 30. And so if you were to split that up, that means it's 14 up and 14 root 3 right. And you do that by doing 28 sine 30, 28 cos 30. That's what that's about. And so resolving vertically, it's 14. Resolving horizontally, initial speed is 14 root 3. If you put the two together, you get 28. Okay. Resolving horizontally, we want S. So 3 things you know, 1 thing you need.
So use 14 root 3 and then A is A 0.
Yeah.
T is 10.
T wasn't 10.
I forgot what T was, right? T. Oh, T was 20 over 7.
Yep.
Yeah.
That's the 3 things we know. What's the 1 thing we want?
S.
Yeah.
So I can now do ut plus half at squared.
Yeah.
And so that would be 14 root 3 times 20 over 7 plus half times 0 times 20 over 7 squared.
That's it. How am I quicker at this than you?
I'm slow.
I'm getting 40 root 3 or roughly 69.2. 69.2. Let's take a look. 69 meters. Yep. Resolving that way. Time was 2 and 6 over 7. Yep. And taking upwards, it was 10. Yeah. So split it into 2. Horizontally, 28 cos 30. Vertically, 28 sine 30. From there, 3 things you know, 1 thing you need. Any questions with that?
No.
Greatest height, velocity is 0. When it goes back down, velocity will be the negative of what it started at. Hold on. So this is up at a thing. Perhaps. Particle is projected from a point. Alright. I just get a feeling we're not there yet. Length of time. No. We'll have to see how we do. I'm gonna try this one. No, I'll trust an old bookie. Right, I'll do it properly. Okay, this one.
Okay, so
And I'm cheating. So that's just the diagram.
okay, so should we draw? Oh no, they've already given us a drawing.
Well, I gave the drawing.
Okay, fine. Okay, so should I find out what theta is?
Why not?
So that's arctan of 4/3, which is 53.1.
Okay.
And so I feel like I need to find out what the adjacent is.
Yeah.
Are we just doing the same thing where we did like part f cos
Yep.
alpha equals 2? And so in this case, would that be f cos 53.1 plus f sine 53.1? Yeah.
Okay, but we want f.
Should we just do f tan? Should we do f sine? Can we divide both of them?
Then you'd just get tan. You'd get the 4/3 thing. So f cos theta is the I. The Pythagoras would give us phi. What is cos theta for this one? Cos 53.1.
So 0.6.
That's not bad.
Yeah.
That's 3/5. And the sine?
So that will be 0.6.
Same?
No, wait, sorry. I put 3/4 wrong, 4/3. So that should be 4/5.
So that's 4/5 times f in the j direction. And let's see. method here. It's tricky. Okay. Let's resolve upwards. What do we get? So let's say to get from its starting point to its end point.
So now we're doing S. Is it now like S is 4/5?
S is the distance displacement.
Oh, sorry, S is 42.5.
And compared to its starting point, how would you express its end point? Come on. I just need to buy a new laptop. Minus, because it's down here. Minus 42.5.
Okay. And so now T is 5.
You're right.
A is minus 9.8.
Yeah.
And we're trying to find out what capital how V is equals to 20.
Yeah. Any idea what we would find for that?
Is it like, do I need to do U equals something?
U is U.
Yeah. And so now I can just do S is equals to U plus half AT squared.
Yeah.
And so if I put that into my calculator, I got 16.
So, what did I put? It's for U. So U is 16. And so we want F. Any idea about that?
Pardon, sorry, what was the question?
So we want F.
Yeah.
Any idea how we do that?
So F is just the speed, isn't it?
Yeah. We resolved in the vertical direction. And so the initial vertical velocity is 16.
So are we now doing it horizontally?
Don't need to. J is the vertical one.
Yes.
And so 4/5 of F is 16.
And so does that mean that 3/5 of F is something as well?
Sure is. Andrey. 4/5 of what is 16?
$20.
Yeah. And there we've shown it's 20. And And how would you do B?
Is that just we can just do like a displacement, can't we?
Yeah, that's just resolve horizontally. We want S, and the three things we know would be time, acceleration would be 0. What would be U? Initial speed horizontally.
Would that be is that going to be I'm not sure. Is it 0? I'm not sure.
It's going to be 3/5 of 20.
3/5 of 20. So
Which is 12.
100 over 12.
Let's see. So horizontal is I, vertical is J. Let's see. Let's do it again. This time it's exam time. Is this exam time? Kind of. Let me see. It's not quite the same thing, or perhaps it is. Buff. Speed. The range of the particle, I don't know what that means. They enjoy snaking me. Just, that looks like it starts up somewhere. Why can't they just give me normal questions? Kind of. Nah, they don't have any that are kind of similar, I don't think. They're similar enough. Speed. Okay. We pushed it, we did what we could. Okay, let's see. What's all this malarkey about? Horizontal and vertical component. You have some force. It has an initial velocity at a certain angle. If you break it down, you can break it down, instead of saying it's diagonal at a certain angle, you can say it's this many right, it's this many up. It's F cos angle right, it's F sine alpha, F sine angle up. And so you take something that's diagonal and difficult and you break it down into right and up, which is much easier. And that's the big picture. And so if its initial speed was 20 at an angle of 30, then that means it was 20 cos 30 right and 20 sine 30 up, that type of thing. And so that becomes your U in the different directions. And so if you're resolving vertically, you use the vertical U. If you're resolving horizontally, you use the horizontal U. What is the velocity at its maximum height?
0.
Yeah, and you use that a lot. What's its velocity when it hits the ground, if it goes back to where it started? So let's say it's projected up at a speed of 15. What speed does it hit the ground at? Or velocity does it hit the ground at? Sorry?
Is it 15?
Yeah, or velocity would be minus 15. Yeah, so what do you give yourself for that stuff so far?
Like 3/4, I think.
That's alright. Yeah, how was that for you, Andrey?
Tricky stuff. I struggled a little bit, but yeah.
That's alright. We got through 1.5 things. It's better than, because I skipped a lot, so I'm glad I didn't do all the extra stuff. Yes, and so any questions for me in general?
No.
And statistics next time?
Yes, please, yeah.
Alright, well done, Andrey. You did great. I look forward to chatting again later in the week.
Yeah, see you on Friday. Cheers, thanks.
All right, take care. Goodbye.